In this circuit, we're given node definitions. VA, VB is up here. Our reference node, 0 volts, is down here. This is a supernode. Its independent voltage is VC up here, which means it also has a dependent voltage VC minus 10 volts down here. We want to write a set of equations from which we can find the current I through this 10 ohm resistor, with positive being in the indicated direction. First, I'll do KCL at node A. Whenever I do KCL, I have to settle on a sign convention. I'm going to assume that positive currents are leaving the node. The current leaving node A through this 15 ohm resistor has a voltage polarity implied to be in this direction. I have to assign my voltage polarity relative to the passive sign convention and the assumed direction of current. So this current will be this voltage at the positive terminal, VA, minus the voltage at the negative terminal, which is V sub C down here, divided by the resistance, which is 15 ohms. The 2 amp source is going into node A. We don't get to choose anything about that. Since it's entering the node, that's the opposite of our sign convention, so this becomes a negative 2 amps. Finally, the current leaving the node through the 6 ohm resistor results in an assumed polarity of the positive terminal being at VA and the negative terminal being at VB. So this current leaving node A is VA minus VB over the resistance, which is 6 ohms. Those are the only 3 currents leaving node A, so those sum to 0. Now let's look at node B up here. KCL at B, we get to assign our sign convention on currents independently at each node, but I think I'll stick with positive currents leaving the node. The current leaving node B through the 6 ohm resistor implies a polarity of plus here and minus here. So this current's going to be VB minus VA over 6 ohms. The current through the 8 ohm resistor leaving node B implies a polarity of the positive terminal being at VB and the negative terminal being at the reference node, which is 0. So this becomes VB minus 0 volts over 8 ohms. And finally, the current going through the 20 ohm resistor leaving node B implies a polarity like this. So this becomes VB minus, the negative terminal is the reference node again, minus 0 volts over 20 ohms. Those are all of the currents at node B, so those sum up to 0. Finally, we do KCL at this supernode. I'll again assume positive currents are leaving the node. The choice is arbitrary, but there's no real reason to change it. The only effect of that would be to confuse myself. So the current leaving this node up here implies this sign convention through the 15 ohm resistor. So this current here is VC minus VA over 15 ohms. The current here leaving node C through the 10 ohm resistor is VC. Positive terminal is here, negative terminal is here. Current has to enter the positive voltage terminal. So this is VC minus 0 over 10 ohms. Notice that when I write this equation, I'm not worried about I. I'll figure that out later. I just want to get the nodal equations written first. Finally, the current in this direction is the same as the current there. That implies this voltage polarity across the 12 ohm resistor. This node voltage is VC minus 10 volts minus the voltage at this negative terminal, which is the reference voltage, which is 0 volts over 12 ohms. Those are also the only currents leaving that node, so those sum to 0 as well. Now we've got 3 equations and 3 unknowns that we can solve for VA, VB, and VC. Now I need to write an equation for the current I in terms of those voltages and the reference voltage. I is positive this direction, so I assumes a polarity that has the positive terminal at the reference node over here. So I is the voltage at the positive terminal, which is 0 volts, minus the voltage at the negative terminal, which is Vc, divided by the resistance, which is 10 ohms. Now I have 4 equations and 4 unknowns. I can solve those for I.